We're going to look at this video at solving a matrix equation, and it's a little bit unusual. So I'm going to show you first of all what a typical matrix equation would be like. So normally you would have to find a matrix X such that maybe AX equals B. And how you go about doing this is you find the inverse of A, and you have to put the inverse of A in front on the left hand side. So you put the inverse of A in front on the right hand side as well. Now this bit here, inverse of A times A, that would just give you the identity, times X is equal to A to the minus 1 inverse of A times B, which then just gives you X is equal to A to the minus 1 times B. Now this question is a little bit different. So this question, slightly different format. So in this question here, it says the matrices B and C are defined by, find a matrix Y such that Y times B is equal to C. Now to get rid of this B, we want to basically get Y on its own. That's what we want to get. So to get rid of this B, I have to actually put the inverse after it, because the B and the inverse have to be touching each other. So the inverse of B has to be after the B. So if you imagine the inverse of B is after everything on the left hand side, that means the inverse of B has to be everything on the right hand side. So it's just really where you put B, inverse of B, sorry, on the left hand side, you have to put it in the same place on the right hand side. So when after on the left hand side, it has to go after on the right hand side. Okay, and then when we work through that, inverse of B, sorry, B times inverse of B just gives you I. It's equal to C times B to the minus 1. That means your matrix that you want Y is equal to C times B to the minus 1. Okay, now we're going to look at actually how we find the inverse of this thing over here. So B, first of all, the determinant of B is equal to, so it's going to be minus 1 times minus 2 minus 5 times the 5. Now what I've done there, it's the product of your leading diagonal minus the product of the other diagonal. So minus 1 times minus 2, just show a wee bit of working out, that's going to be 2 minus 25, that's minus 23. So my inverse of B is 1 over your determinant, so I'm just going to write that as minus 1 over 23, and then what you do is you swap the elements in the leading diagonal. So the minus 1 and the minus 2 switch around, and the sign of the other two elements change. So they were both positive, so now they both become negative. So that's all it means. Change the sign of them. Positives become negatives, negatives become positive, and that is it. Okay, we're ready to get started then basically. So Y then is equal to our C, which is 2 minus 2, 3, 3, times then minus 1 over 23 times our inverse of B, which we've just worked out to be minus 2 minus 5 and minus 5 minus 1. And then we could write that as just a mess, having that minus 1 over 23 out in the middle there. Just put it this way. And then we're good to go. Okay, right, multiplying matrices. Okay, right, think about where these points are, these elements are, I should say. So this first element is in the first row, first column. So what I'm doing is multiplying my first row by my first column. So that means I'm doing 2 times minus 2. I'm doing this with my calculator here just because it's easy to make mistakes. So 2 times minus 2, and then plus minus 2 times minus 5 in one go in your calculator, and what I got was 6. So that was my element in the first row, first column. Next of all, I'm doing first row times the second column. So what I'm doing here is 2 times minus 5, again on the calculator, 2 times minus 5 plus minus 2 times minus 1, and that equal to minus 8. And then we have got, that was our first row, second column. Now we're doing our second row, first column. So I'm doing 3 times minus 2 plus 3 times minus 5 on the calculator. That gave me that gave me minus 21. That gave me minus 21. And my last one, second row, second column, second row times my second column. So again on the calculator, 3 times minus 5 plus 3 times minus 1, and that equals minus 18. Now have a look and see In an ideal world, these things would be divisible by 23. So maybe you say I had y is equal to minus 1 over 23 times 46, 0, 23, and maybe 46 minus 46. I could multiply in by the minus 1 over 23. I can't. I don't think it's going to make it any better. So I'd leave it as it is. And there you have it. Done.